Hi, the best way to learn something is to do more problems. So we're going to have example 2 on spring elements. Please look at the figure here. We have two rods linked together, but they have different area, cross-section area. They have same length, and both note is applied with force. Same as what we had before, we change all units into meter square and change the gigapascal to Pascal, and we find out K1 and K2. For now, you should be able to uh, figure out the local stiffness matrix for each element. Okay, for the spring elements, the constant is the same, and the spring elements format is always 1, 1 in the diagonal area, and then the other two entries that 1, 1. K2, okay, nothing fancy. We have one matrix for the first element and another matrix for the second element. Now we can know we can learn how to link them together. Okay, so we have K1, K2, two elements. Okay, K1 and K2. And first step, we must name the nodes. 3 nodes. Okay, and all the movement on 1 is called U1, and all the force applied to it is F1. Same thing for the 2, and the same thing for node 3. Okay, now let's write down into equations. F1 is K1 is all the movement. F1 is causing all the movement from U1 moving against U2. F3 is same thing. F3 is causing all the movement of U3 moving against U2. F2 is kind of tricky here. It's dealing with two movement. Let's do it one at a time. K1, and it's causing all the movement of U2 minus U1 plus the second portion, which is K2, which is the U2 minus U3. So let's group them. Let's group the equation into a more friendly format. Plus K1 U2 plus K2 U2 plus 2 plus K2 U3. Okay, look at that. We have a constant here. We can factor U2. So we can rewrite the equation like this way. Sorry. finally, we can factor out the displacement factor, U1, U2, U3. Okay. Did you see that? Right here, the first portion of the matrix is the local matrix for K1, and this is the second portion of the matrix is the local matrix for K2. So this is how you link together. So instead of a 2 by 2 matrix, now we're dealing with a 3 by 3 matrix with a 3 nodes and 3 nodes on displacement. So let's put this back to the equation there. And we all know from the previous pictures, node 1 has 10 kilonewtons and node 2 has 10 kilonewtons and node 3 is 12 kilonewtons. Ten to the 3, and this is 12 to the 3. Okay, and U1 is 0 because it's sticking against the wall, and U2 is moving something, we're about to solve it, and U3 as well is moving it. So let's plug. We all know K1 up there, so let's rewrite it. To the 9, 4 minus 4. Okay, so we have 3 equations and 3 unknown. We're going to solve this. Let's work on the second equation first. 10 to the 9, and then 0 times -4 is nothing, and U2 times 4 plus 2 is 6U2 minus 2U3. Okay, and the third equation is 12 times 10 to the 3. Okay, 10 to the 9 U2 plus U3. Okay, this is -6, and right here this is -6 as well. Factor out the equations, and then it becomes 22 times 10 to the -6 to the 4U2. U2 is only 5.5 times 10 to the -6 meters. Plug in the equation again, you can solve out U3 is 11 times 5, 10 to the -6 meters. And now you know U2 and U3, you can find out F1 is times 10 to the 3 Newton. You check with the free body diagram. Up there, we have a force acting to the right on node 1 is 10 kilonewtons, and node uh, 2, the force is 12 kilonewtons. In total, there's 22 kilonewtons to the right, so which is correct. F1 has 22 kilonewtons to the left. Thank you very much.